Hi, today we're gonna be building hexagonal architecture from scratch, um, TypeScript and Bun. You've probably heard of names like pods and adapters, clean architecture, onion architecture. It's the same idea where you keep your business logic to the middle and push databases, HTTP and frameworks to the edges. We are gonna go into that in detail a bit. But I just want to start by why should you care about this, right? One reason is because your use case don't know about what database you are using or framework you are using. You can swap uh, around those things, right? For example, maybe I started your your project using Prisma. You can just swap it with in-memory database or MongoDB, something like that later on, right? So we are gonna be looking at the domain, right? The pods, right? Adapters, and the composition, right? So adapters, they are driving adapters, they are also driven adapters, right? We are gonna explain this a bit more, right? So we are gonna be explaining this and then doing a code implementation of it, just using a user, right? Creating a user, and then yeah. So let's explain each of these what we see here on the screen. So it's just another architecture pattern where you structure your code or your application, right? So it's mostly used for when you want flexibility and scalability, right? So mostly used with what you call microservice architecture, right? So yeah, so let's look at this diagram here. So you have the domain, right? So this is your application that you that is unique to whatever is out there on the world, right? So let's say you are building a social media platform. This is where your rules would go in most. What type of users do you have? How does the user creation flow happens and what rules around that user, right? So this is the domain. So this is what is unique about your application, right? So it doesn't know anything about if you're using a GraphQL API or you're using an HTTP API or is a console application. All it knows it's your business rules and what things exist within it, right? So it only knows what the user is, what these risk failures look like. So this is where you'd have your internal exceptions, types of exception that you have. Maybe user already exists, things like that. Not that in the database the row already exists, but it would know that the user already exists, right? Not this database row already exists, right? So what are some of the things that you should look out for here? So it should only know about your business and shouldn't know anything about the outside world, right? So let's say you're using a Postgres with Prisma maybe. Once you call Prisma or this part of your domain knows anything about your Prisma, that you are using Prisma or you're using SQL database or anything like that, you have to restart the architecture. Unfortunately, there's something wrong that you have done already, right? So let's move down to the pods. Right? So there are driven pods, there are driving pods, there are driving driven adapters, there are driving adapters. So let's look at the pods. So what comes into your domain is the driving one, right? So what goes out from your application is the driven one, right? So for example, your logic is here sitting, right? So for it to start creating a user, it needs to be driven, right, by this side. So they are driving, so they initiate the communication or uh, the execution of your business rule or your domain area. And then your domain area then initiates communication with these driven or driven adapters, driven pods or driven adapters. So these ones they ingest, these ones they output. So get a new user, create, I save the user into the database. Right? So I got a new user and I saved it in the database. So it's something like that. And then we have composition, right? So composition, it wires up everything together, right? So in the HTTP, it can be a controller, right? That wires up everything, or a service. Yeah. So yeah, a service. We're gonna be looking at services more, right? Or call them use cases. Right? So pods, they are mostly contracts, right? So it's what the app, right, uh, accepts to the inside, right? So controllers or CLIs, right, they need to satisfy the contracts that are the inbound API, right? So how we receive data into the domain. So they have to conform to that and supply all of that information, right? So we call this site use cases, right? So um, it's a use case. So it's a user use case, it's a create user use case, is a, things like that. So what can I do in this domain, right? And then driven pods, right? So driven pods is application contracts, right? Uh, and then the infrastructure that wants to receive or that is gonna be receiving information from the domain, right? It needs to implement. For example, let's say we have Postgres database here. The domain doesn't need to know about the Postgres here, but it defines the port, right? I need a, uh, a save user function. I need a find user by email function. So now the adapters here will implement those interfaces, right? To say, okay, I want to be a Postgres database that is used within this application. So now I will provide you a function to save a user, right? So I will implement it however I want, but I will accept the information how you send it, right? So the domain sets the contract, and then these ones they conform to the contract. So it's the same thing both sides, right? The domain has ports which it specifies this is how I will receive information, and this is how I will give out information. And both of the adapters they adapt to that contract, right? So in this case, you'd have your Prisma, and then that Prisma implementation conforms to how the domain wants to save the user, right? And then let's move on. So we said left side is the driving adapters, right? The inputs. And then the right side is the driven adapters, the outputs, right? So let's look at we have a composition here, right? So a composition layer wires up everything. So you can initialize the database adapters, the driven adapters, the driving adapters, um, things like that. Right. So in this case, since we are using the user as an example, so our user service will build those adapters and then driving adapters with the service use case, right? And then everything else will stay clean because this file is allowed to know everyone. So this is the only person knows about which type of adapter we're using, the in-memory one or the Postgres one. It also knows which type of driving adapters do we have, like is it in HTTP API, console application, or it could be a Kafka listener, it could be a worker, it could be anything that can send information to the port, right? And then this side is anything that can save or consume information that we want to export from the application and stuff, right? Okay, cool. So speaking about those, so we explained this, right? And then, yeah, so it's hexagonal architecture. It's because it can have many inputs, many outputs in any direction. So uh, that's how it is. But this is what I can explain it with, right? Okay, let's go look at the code implementation for this. Right. So I have my editor here, Cursor. Yeah. So we are gonna start by creating the folder structure, right? So I'm gonna start by just initializing a new project here. So that is just blank, right? Yeah. So we have our project here. So let's look at how we can structure the folders for these, right? So we talked about ports, we talked about domain, we talked about adapters, right? So let's first, sorry. So let's first create our folder structure, right? So usually I just start by the source folder. So just I have everything inside here. And then within my source folder, I'm gonna have three folders. Right? It's gonna be application. Uh, okay. And this is supposed to be a folder. Why it's taking me to a color screen to edit. Yeah. So inside the application, supposed to be a folder. Let me that. So it's gonna be application, and then still inside source, it's gonna be domain, and then here gonna be right. So inside of each of these folders, we have parts of our code that will be going there, right? So the simplest one is the domain, right? So in the domain, you are gonna have things like your models, your exceptions, things that you are like are within your domain. And then inside application, this is where we are gonna have the ports, the services, right? And then inside infrastructure is going to be the adapters, right? So it's the infrastructure that we use to adapt to. So also is in and out, right? And then inside infrastructure, we're going to have our composition also, right? So let's finish the folder structure of application. So inside application, we're going to have the ports, right? So it can be in or out, and then we can have the service also, right? And then that's that, right? And then let's go to the ports. We said in ports we can have an import, and then also we can have an output. So import is the driving side, so it's this side, right? And then output is the driven side, right? So where do we uh, save our information, right? So mostly interfaces that define the contract on how we want to action these things, right? So, and then we go to the domain. In the domain, we said it's objects that we understand. So we can have exceptions that are understood by our application or that are unique to our application. We can have models, right? So models is, in this case, it's going to be the user model. So because we are just creating a create user, right? And then inside our infrastructure, right, we are going to have adapters. So inside the adapters, we are going to have an in adapter. Also, we are going to have an out adapter. So same thing, adapters, they are in adapters, they are out adapters, right? So also remember that. And then inside infrastructure, we said we have also our composition root, right? That knows about everything that wires up everything together, right? So we are going to have that inside our infrastructure config. So because this is mostly configuration, it mostly knows about everyone else, right? Right, so it's just a TypeScript file. Let's read that. What am I doing? Yeah. So yeah, so we have our folder structure. So this is the complete folder structure. Obviously, it's not limited to this, but for our use case right now, it is complete, right? You can define many more other folders, like utilities, things like that, right? Okay, so let's start to create our domain layer. We're going to start by our domain layer. So in our domain layer, that we have models. So let's start by a model because everything here is about a user. So it's just a normal TypeScript file, right? And then we are gonna have a user. All right, so a user can have an email, uh, email is a string, right? And then ID is a string, and we can have a 20 to create this user, which is a date object. And then you also have a password. I hope you know that we don't store password as they are. store passwords as hashes. So we have our user object, right? And then we are also gonna define, right, a factory that will create a user for us every time we get it from the database, right? So it's gonna be a function create user, right? And then it takes in some properties, and then those types of properties is gonna be created, the date, right? Um, uh, that's gonna return a user. Sorry about sound. Let me check if it's still recording. Okay, awesome. And then we're gonna return a user, right? So created at props dot created at, right? Email. Uh, okay. Um, yeah. Yeah. So it keeps the construction consistent and the documents the shape of a valid user, right? If you are just wondering, I don't just call and create a user manually ourselves. So it keeps it consistent so we know our user always, no matter what props we pass, these fields must be specified and we are gonna get this type of user back, right? No matter where we call this function, right? So it's a factory function that is only used to create a user given an input, right? So that's our user there. And then let's go to our exceptions. So we start by creating what is unique to our application, right? So we're creating a domain error here, right? So then error, then after fixing which is a string, then it constructs the error by calling the super, and then we pass in the each and give it a name is equals to our domain, right? And then have another class, right? So a user already exists. So you don't have to know these things before you create them, right? So it takes in an image. So I won't say string here because the caller needs to at least know what they need to pass here, right? And then now we call our super again. Now here it expects a message instead of an email. So we create a message of and then we give it a user already exists, right? And then we are gonna have another one, just a weak password checker, not a weak password, a big weak password error. Then it extends. So it has something similar. Here we cannot accept the password and show it back, but we can say what's the error. And then this one is a weak password, right? Error, right? So that's all we are going to have in our domain layer. So we have our domain error, right? Our generic error. And then we have our specific errors, right? So it's where you would have like a Prisma error, maybe row no found error, things like that, right? And now we are gonna move to the next one, right? To the pods out, right? So we define how we want to save things, right? Sorry about that. So how do we want to save the user? So it pods out. So when we save the user, how do we want to save it? That's what we are doing now, right? So it's a user. It's a repository, so defines an interface of how we want to save a user. But user repository, right? And we want to be able to save a user. So given a user, then right, we want to save a user and then expect promise and say user is saved, or the user can be null if something happened, right? But our user here, when we look at it, it says here we already have ID and created at. So when we save the user, we don't have the created at, don't have the ID at this point. So we need to skip these so that they can be generated by the adapter. So if Prisma or whatever needs to generate this, right? So in TypeScript, you can omit certain fields, right? The user, omit the ID, and create and created it. So now when we come back to our user, it omits those, right? So our user omit ID and created it. So when we save the user, I won't have our ID and created it. Fine. And then what else do we want to do? We have a user already exists error, so we need to find a user by email list. Right. So given an email, which is a string, right? And a promise of user that we found or not. Maybe we didn't find it, right? Then we also find all. So maybe we want to get all the users at some point, maybe send them all emails. So this one will return a promise of an array of users, right? Not all null, just get an empty array here. Cool stuff, right? So now we have our user here, right? This is our user, our model, we have our errors, and then we have our repository interface, right? So this repository is just an interface. So we are just defining how we want to save a user, right? How we want to save a user. So we are defining a driven port here, right? We haven't reached the data part yet, right? We only defined the driven port. We haven't even defined the driving port, right? So that's what we are gonna do next. So an import, so that's the driving port. So when we create or when we receive a create user, right? Right. Uh, create user use case, right? Remember I said in are use cases, and then out are repositories. Yeah, can be calling an external service, could be calling a database, could be calling an in-memory data store. That's still a repository because that's where you save your information, right? Okay, so our create user here will have a spot, right? A type that we will be uh, accepting, right? So it's usually called like create user, the command, right? So we are commanding our domain layer to create a user, right? So we are expecting an email, which is a string, and also we are expecting a password, which is a raw password at this case, right? Which is also a string, right? And then that's the type that we are gonna be accepting in, right? But how are we gonna be accepting it in, right? So we've defined the contract. Let's define the inbound API. So to say, if you want to call me, you must implement this interface, right? Called create user, not command, use case, right? So now when you want to create a user, you must implement this interface with this command. Right. And then you can expect a promise with a user. Right. So when we create a user, this is what you can expect back, right? A user and when you want to create a user, you must implement the create user interface, right? Cool. We said we also have a get user, so find all users, right? So let's also implement a get user use case, right? Um, uh, so it's gonna be a simple interface, but get a user back, and also you can get all users, right? And then you can expect promise of a user array. So that's all with this use case, right? Cool, right? So that's the in, right? Those are our input, and then we already defined our output, right? Let's try to wire up a service right now, right? So we are wiring up a user service, right? So our user service, implements, right, both the create user use case, right, and a get user use case, right? It is a user service after all, so it needs to be able to create users and get users. So it implements those. So that's gonna shortcut that to implement all these methods, right? So create user is from create user use case, get user from get user use case, get all users is from get user use case. So now our user in our service implements these use cases, right? So this is how it receives data, right? Okay, cool. Now our user service needs to save data, right? At some point, it needs to save data, right? So to save data, we have to inject, right, our dependencies or how we want to save data, right? So it's gonna inject a private read-only user repository, right? User repository, which is a user repository, right? Right. Cool. So now this is how it's gonna be receiving data into the service, right? The commands, the email, right? And then this is where it's gonna be saving or how it's gonna be saving because we haven't defined the adapters, right? We are still just on the ports, we are at the user service, right? So let's look at our create user. So let's get away with that. So to create user, obviously there are some rules to creating a rule, a user, right? So this is where our business rules come in. So first of our rules is to say if, right, your password is weak, right? Command dot raw password and its length is less than 8, right? 8 characters. That's a weak password. That's our business rule. So we're just gonna throw a new, right, domain error. So that is understood by our application. So which is our weak password error, right? And then that's it, right? Don't return anything. We just throw that this password is weak, right? Next is before we create a user, we need to know that this user doesn't exist, right? So const email. So another thing that you right, another thing to take note just outside of this tutorial, outside of this video, you don't really trust user input. You must always validate user input to be is what you are expecting and transform it to how you want to save it so that is consistent throughout your application. So in this case, we are making sure that the email doesn't have spaces and then it lowercase, or we can also like use a right like Zod. Oh yeah. So we can use a validation library to validate these things to ensure that they conform to what you are expecting, right? And return a bit more detailed errors on why we failed that, right? So, and then the next thing would be to find if this user already exists, right? So gonna await, right? So this needs to be as gonna await our user repository, right? Dot find by email and give this email. So if existing user, we found an existing user, right? So we want to throw that this user already exists. And then it expects an email. So now we specify that this user already exists, right? And then we return, right? Uh, user repository dot save, and then we can expect a user that has some fields omitted. So we're only expecting an email and a password here. So we just pass email there, and then a password hash, right? Uh, raw password, right? So okay, so this save command can never return null. Yeah, this would never return null because we are saving the user. So we return that, right? Cool. So now here we need to hash our password because we don't save it like that. right? Because it's not secure to just save the raw password, right? So also for that, we can have a password use case, not a password use case, but a password repository, right? So that handles password hashing, validation, uh, things like that, right? So here, right, we can also like take these out of here into that service or into that implementation, right? But for now, I'm just gonna do something simple, right? So here, we're gonna define our password. Um, so export. So we can hash the password in many ways. Pass. Can use external services to hash the password. Maybe we can use internal services to hash the password, fine. And then can expect a promise string, right? Can have a service to hash a password, right? I don't know why you'd want to do that, but it's possible. Nothing is stopping you. Then you will just get a boolean to say the password is strong or not, right? Then we come back to our user service, then add another private one. Right? And then here, instead of just passing in the raw password, we await password hasher dot hash. So get a hashed password, and then we save that hashed password. So let's just introduce another variable here. I used to think as you introduce many variables, code would be slower when I initially started coding, until I got to work with an enterprise system that had many variables and would finish something or a process faster, but it would be like almost like 50 lines of code with many variables declared, single-used variables just for better readability, and it would just instantly finish it like that. And I started to write more readable code than like chaining things together. Right? I thought I was saving some time by that. But yeah, that's just a side joke or a note. Yeah. So as I was saying, right, we can have many ways of hashing our password, right? Like we can hash it in memory, can use different algorithms, right? So we can have implementation for different algorithms. Can use external libraries to hash instead of the node crypto one in JavaScript. Maybe we want a specific one, so You can also introduce that uh, with the password hasher. That's why we implement it like this. So that one day, if we want to move away from in-memory hashing, maybe use a external library, we just implement this interface and then we pass it in. Or if we want an external service to do that for us, we can do that. I don't know why we do that, but yeah, you can have a password hasher service, hashes password. Verify if it's a correct password, but yeah. And then one thing that I'm seeing here we can move is this maybe maybe you say is strong, right? The raw password, the string, and then we return a promise book. Whether the password is strong or not, and then return that, right? So let's call this here. We have to await it. Right. Yeah, I don't like code written like this, awaiting inside. I would introduce another boom, use this. That. Right. Cool. So now the password hasher, well, we could call it a better name, maybe password service or password util or password something, right? But it doesn't matter. I'm just gonna stick password hasher. And then it does anything that is related to the password. We check that our password is strong. Because now, if we were to implement another service that also create a user, but maybe in some other way, right? We would have to remember the business rules that we were hard coding here. But now that service would just say, oh, I need to hash a password. So there is a password hasher. It's calls in that password hash and then we hash that password. So that's the nice thing or writing code like this. So it's scalable, right? Cool. Good stuff. So yeah, and then here we are getting a user, right? So we can just say return, right? Okay, we find the email first here. Right. So a user in the user repository, it can be null. So that's the squiggly line we are getting there, right? And then so we need to introduce a step here. Is no user returned. Otherwise, we return the user. We want to throw just domain error from user. Let's throw a domain error. Can define user not found. This would depend on your rules, on how you want to handle this. Maybe you don't want to expose it. When this made, not this made, and we import this. Right. So now we have our user not found. And then here we just return. Wait. Just return all of that. So that's our user service, right? So that's how you would write it. This has your business rules. This is where you implement your business rules, right? These define on where you save, how you interact with external dependencies that the service needs to depend on, and this is what the service receives in, right? So yeah, can move on again to let me see. So we have our create user use case, get user use case. We have our password hash, password repository. We have our user service, our exceptions. We just added one more of user not found, and then we have our model, which is our user model, right? So now looking at this, we're pretty much done with this domain part and the ports. We don't have the adapters. So we don't have the adapters. So that's what we are going to be doing next, right? So in the infrastructure, those are your adapters, right? So your infrastructure has your adapters. So that side would be the driving adapters, like how do you receive the request to create a user, a command to create a user. Out, how do you actually persist this user? How do you save this user, right? So that's that. So let's go into first the out adapters, right? So we are gonna create a new out adapter, right? So can be Prisma, can be in memory, right? So for this demo, I'm just gonna be creating an in-memory adapter. I don't want to spin up a Postgres container or database. So we here user storing. Yes. So we have our user in memory repository, right? So class that is exported in memory. Right. Also, when you have a user in memory repository, it's simple, right, to test your application. So when you are testing during test, you can actually use these to test your service business rules, that they do what you expect them to do. And then in production, you can swap out that in-memory repository with the actual implementation of a database. So it can be a Postgres user repository or a SQLite user repository or a what you call any type of database that you're using, a file, external service call also that maybe you call. Yeah, so it doesn't have to be really a database. So you can actually call another service for this, right? So it depends on a downstream service to store your user information and tell that service to say, okay, we've validated these roles and then we've transformed and stuff. And then can you just create this service? Obviously, they have to also do the validation on the side because you cannot trust user input, right? So let's look at our in-memory data store, right? So this is a repository and we've defined this is how we want to save it. A contract, when we save a user, this is how we want to save it. So this in-memory repository needs to implement that repository. So we are gonna use a user repository, right? A user repository. I'm not. Oh, Java. Yeah, and then just implement those, right? So since it's an in-memory data store, we're gonna have a private variable here that is read-only, right? Users. So this is our database otherwise, and so it's just a list of users that we initialize it empty, right? And these methods need to be async, right? That doesn't initialize that like that. Okay, cool. And then let's start by find all because it's the simplest. So we just return, copy this array, want to return this actual one because if it was to be modified somewhere, it would actually modify this one. Cool. And then let's return finding one user, right? Find by email, right? So here we can simply like return users, right, dot filter, not filter, but find, because filter would return multiple, but find supposed to find the first one, right? Then the user dot email is equals to our email, right? Otherwise, we want to return a null, right? So another thing to take note here, just security note, this is an input and this in-memory repository might not be receiving input from our user service here, right? So we might want to again normalize the email, right? Right. Then extract this into a utility function. If we are doing it quite a few times, right? We are doing it quite a few times, right? Because we might receive an email that has a capital letter and here we are strictly checking that is equals to, right? We are not saying almost like or something or to lowercase, get to lowercase. So we want to say all the users that are here have normalized emails. And when you are searching, we are normalizing the image. So that's a security consideration, right? That you must have, right? And then let's implement our user, right? So const here, we have a new user that we want to save, right? So we are gonna say user repository. Okay, we don't have user repository, but we are pushing the user to our users, right? We are saving this user to our user, new user. Sorry about that. And then we return. Okay. Now, how do we create a user, right? Remember, we can just maybe say, okay, this is the user, this is the user, but we want it to be consistent across our application. We created a create user factory function, right? Factory function. So this function creates a user for us so that every time we know that a user will definitely have these fields, right? We can even further go inside the factory function um, to to implement some rules, maybe null checks and define checks. Okay, this is not a good variable name. Right. So we're saying it's user data so that we can distinguish from the right. So user email and then password hash is gonna be user data password hash. We are hashing it on the service layer, and then we have an ID. We are just gonna use a crypto dot random UUID. So just create a random user. Cool. Fine. So this is the factory. So it does. We want to say when you want to create a user, you must have these things, and then this is what you are gonna give back, right? Cool. So yeah, in our service layer, you might notice that here the email that we are passing, we've already sanitized or validated it and stuff, but this in-memory repository can be called by anyone. So we might want to again normalize that email, right? Again, a simple step, probably the CPU doesn't even feel it. So yeah, cool, that's that. As I've said, we are doing this a couple of times like this. We're doing it here, here, and the other side. We can actually extract it into a user utility, right? That's our email utility or something like that. That actually does this for us. And yeah, okay, cool. We have our in-memory user, right? But if we were to run this application or try to compose everything together, we would get an error that we don't have the password hasher. No, password hasher, right? Yeah, it would complain that we don't have a password hasher implementation, right? So let's implement that. So also is out, right? So let's just use Bun. You can use Node. You can use an external library. So we call it like this. We prefix it with the adapter implementation that you're using, because could also have like I don't know, um, a library, right, and has its implementation, right? So now when you want to differentiate files and stuff, you can look at the files here, right? And also have Prisma user repository or Postgres user repository, right? So yeah, things like that, right? So let's implement our Bun password hasher. So it's a class that is exported called Bun password hasher that implements, right, password hasher, right? And then what does it need? It needs right. So is strong password, well, we just return raw password dot length is greater than 8. So if is strong password, let me just validate that we say is not strong password, right? Yeah. Then is strong password is greater than 8 or equals to 8. Right. And then how do you hash our password? Well, Bun makes it simple. And just hash the password. And there you go. Get your password back, and then and this is why I like Bun, because it's actually easier to do things. They have things pre-implemented for you, right? So here, in this case, you verify, right? It takes in the password and the hash, right? And you can optionally pass the other options like the algorithm. Same here, right? You would want to both pass the algorithm, but right now I'm just using the default. So if I had a specific one, I'd have to specify it here and here so that it hashes that using that algorithm and also verify using this. Right? So cool stuff. Um, we are done with our password hasher. So looking at this, right, we are pretty much done with this side, right? So we can swap these things however we want, because we just come here, implement it here, and then in our compose file, that's the only one that needs to know about this, then we go. We don't have to ever touch the user service. We don't have to touch any other part of our code if we want to swap something out. That's the strong selling point of a hexagonal architecture. Yes, it's a lot of code. We would be done if we were using a straightforward or a layered architecture, right? We would be done, but this is a lot of code to do this, right? So, because actually most of the files here don't do anything as interfaces. For example, this is 4. Right? These are all interfaces. That actually does something is the user service, right? And then let's go to adapters, the in adapters, right? So in our in adapters, we are gonna implement um, let's start with the console because I want to implement both of them. Right. So let's start with the console one. New so remember console, the implementation of it, of the adapter. So what does it implement? The user adapter. Right. So it's a class also. Right, so it's a adapter. Okay, cool. So we said our service here, right? It's a create user use case and get user use case. So that's how it expects to get things in, right? So, right, we need to our console adapter needs to pass in the values like this, right? So we go back here and then we have our constructor, right? Constructor will have our private. So when it wants to create a user, it must call the create user use case. And then if it wants to get users, that's how it will get the users. And then that, and then, okay, this is, yeah, okay, so this is what it's gonna receive, and that's what it's gonna do. So it's gonna return a promise that has nothing, because this is the console where you're returning the data to, right? And then an input to our console will be the email, which is a string, and a password, which is a string. Well, it's a raw password, you can specify that. Yeah. So another one, another promise void, right? And then it will do something, and then Okay, not a very descriptive. Right? So yeah, and then we're gonna have a helper method here that is gonna be printing errors for us. Receives an error that is unknown, and then based on the error, if the error is an instance of our domain error, so now we know at this point what type of error is this. Console.error, and is a business error. Right. Otherwise, oh sorry, so that we don't down. Otherwise, just print out the whole error. I know this error, so print all of it. So let's implement the methods inside here. Right. Pretty much you can tell what is gonna happen at this point. Right. So we are gonna try to do something because remember we throw, right? So when we throw, we just want to say this dot error and give it the error, right? So that one doesn't return anything. So let's go back here. So we want to say const what are we doing? Creating a user. So our user is gonna be false to, right? Await dot but user, not user, but call it create user dot create user. That's a bit weird, but yeah. And then we just passing the input as we get it. Input we have email, have a password, right? So that's the user, right? And then once we don't do anything, we can just print out in the console that the user was created successfully. Okay, so the user was created successfully, and we could log the user. Okay, so we log that the user is created successfully, right? And then sorry about that. Okay, So we handle list all users, right? So we try also, and then we catch the error, right? At this point, we don't know what the error is, but we have our error handler here that will translate the error to a business error if it's a business error, right? So let's get our users. Await. And then we just console log all the users. Let's map and remove the password. Something that we could also do in the service layer, I think. Instead of just maintaining them like this, also we can argue that we need to do this in the repository layer. So according to the rules, how do you want your user to look like when you return? So for now, just to keep things simple, maybe removing them at the business or service layer. I'll just move it here, and then just gonna have an email, and then an ID, and then we're gonna have created it. Yeah, just gonna print out an string. Visible, right? Cool. Yeah, and then handle get user by email. So we need to start by trying and catching the error, and then is equals to get user dot get user, and then send the email, and then we just console dot log the user. So I think our get user already handles user found. Yeah, so if there's no user at this point, we are not gonna get that user, but yeah. So that's our console implementation, right? So now let's move on to wiring everything up so that we can use whatever we've built so far, right? And run it on our console. So we said we have a console now. So we have all these layers, right? for this HTTP part on there, right? So we're going to be testing the console, and then we have said we have a composition, right? So that wires everything up together, the ports and the adapters, right? It wires everything up so that we can call it. In Java, you would use dependency injection, right? And it would auto-wire them, right? But here we have wire those manually. So we're going to have a composition file, right, on our infrastructure config. So it compose, right, right. Okay, so it's going to export a type. So you're familiar with app, export the app and initialize the app. All right, so now we we compose our app where it has a user adapter, then it has a user service, right? And then we export function that composes them. So as I've said, in Java, you don't have to do this because dependency, auto-wiring, bin, for scanning, creation and stuff. Java does that for you. So let's the const initialize the ones that don't need any injected on themselves, right? So for example, it's our head hasher doesn't need anything to be injected on it. So this is where you choose which one you want to use, right? So we want a bun password hasher. So we initialize that. So let's say we have multiple and we use one based on environment. Right? So this is where you would say process.env dot node env equals to maybe in production. In production, maybe you don't want to use this one. You want to use the new. Let me create. Let me actually create, but we want. Okay, yeah, this one. Just use that one. Just right, and then it also a hasher, and then just in those, but we are not them, and then we come back here, saying we are gonna be using. So now you can pick and paste based on the environment, saying password hasher, right? We are going to use this one, the outside lib when we're in production, and then we're not going to use this one when localhost. We are going to use this one when you're in a test environment. We are going to use this one if the application is this type of application, all of that stuff. So, yeah, sorry about that. Yeah, so now we're just going to stick to the bun one and forms. Another one that doesn't need dependency injected is the user repository. So for the user repository, we are using in-memory repository. Cool. So the in-memory repository implements the user repository. So we can come back here to like that, right? So anything that implements it and to that type, right? So this one implements Azure. So we are guaranteed to have some of these methods that we there, right? And then move. So now our application call, sorry, the user service, right? So we initialize that user service equals to right. So our user service, as you can see, it implements these two, right? So can do something. So how we join these, and then it has a repository and a password hash, and then now we can initialize our console application, right? Given the user service and right, user service. See why does it can have create user and we have get user. So our user service implements both of them. So we are gonna put both of them, right? And then we return, right? What does it want? The console and the user, right? Service here. Okay. So we can that side, but what we can do is sort of is specified here. Satisfy. Probably it's because I splitted these two. It could have been one repository. So yeah, good. So we've wired up that, fine. So now we have composed our app, right? So this is our app, right? So we can just call app and get um, access to these two applications, right? So let's try to wire this up to our application, right? So we are gonna create an app, compose our app, and then from that, await, we use the console one, right? And then maybe let's create a user, right? And then our input is gonna be email. The password is the right, and then try to create an user that with the same email, and let's create another user with a invalid password, and then let's create another user. Here we have 3 users. Okay, we're gonna have these 2 users at this point, and one is a duplicate user, and then let's have a yeah, then that's fine. Let's handle get user by email. Let's get that user that exists. So this user exists here, and then here it was a duplicate. And then let's get a user that does not exist. And then let's just print out the users that we have. And don't take right. And let's try to run this. Okay, I'm in the index one. Fine. So come back here. Okay. we're not away. Yeah, let's try that. Awesome. So we created this user successfully, and then the user already exists. There's the user, and then we get our business error. The password is 8 characters, right? And then we were getting the user. We found the user, and then this is the user that does not exist. And here is a list of users that were created, right? So we try to create this one. So in our index file, so here we're creating a user that one. Here we're creating an existing one. And then here creating a user with incorrect limited password, right? And then now we're gonna have user number 2. So if we just clear that up and run it again, we should end up with 2 users at the end, right? So we have 1 user, second user, IDs, and all of that, right? Cool. So that works fine, right? So now you can bundle this as a console application, distribute it, um, and anyone who wants to use it uses it, right? So that's one. Now you have a console input. Later on, you want HTTP API. Just come here in the adapters, right? You say HTTP, please bun HTTP user, right? And then you do the implementation. And then let's say in the future you don't like using bun because you are dependent on bun too much. Not that you are dependent on bun too much, but you want to change frameworks. So for our current service here, the only things that you would need to change is the bun password hasher, because this one depends directly on bun, right? Maybe your new runtime doesn't have bun, but you already have this one, so you don't just continue with this password hasher. and you just change the bun HTTP to Node or Express. Right, and then you do the implementation. You come compose it down here, user console, bun HTTP express HTTP, right? And then you just swap around those ones. And password hash, I just come change here to uh, outside leave password hasher, and then your application continues as normal. Don't have to touch your user service. You don't have to touch your repository. Everything continues the way it was. You just swapped the adapter, right? So yeah, I think I'm gonna leave it here for now. There are some other benefits into writing code like this because you can test it easier, right? So let's say now I wanted to test my service. I just come mock these two, and then I test everything else that is inside here, provide most of these, and then I test my logic to test the repository. I just come explicitly to the infrastructure, adapters, test this alone, test this alone, test this alone. Anything I change in this doesn't affect anything else in the application, right? Just affects that implementation of it, right? So what I'm saying is this is easier to test. It's easier to send, right? It's flexible to add new adapters functionalities. Just you plug in something else to remove whatever you don't want, right? So looking at our architecture again, we've implemented all of these, right? Yeah, so I would like some comments, subscribe, like, share the video, and also like comment on what I can do next. Or do you want me to explain something further again or explain this in another language? Yeah, so looking forward to hearing from you.